right, let's see how you did on your assignment where you were understanding the concept of standard deviation. So this first question had asked you to calculate the standard deviation of these 6 numbers and show all your work. So I had given you that table to do that. So the mean was 8, and then you had this similar table where you had to then put all of your observations, your 6 pieces of data, find how far away they are from the mean, and then square them. Square those differences. Why do we square those differences? Because if I summed up these values right here, they would sum to 0. Okay, so that's the problem. All right, so then we summed instead their squared data, and that's 130. Then we want to divide by n minus 1. So there was 6 pieces of data, so I divided by 5. That's 26. So that's the variance, okay? And you need to know, that relationship. So that variance is the standard deviation squared, okay? So that is another thing that you need to make sure that you understand. All right. And so then when we take that square root, it's 5.099. Now, explain why you could have looked at the data and determined the answer by just having an understanding of standard deviation without doing all the calculating. Well, once I see that the mean is 8, okay, well, if I take a look at this data here, I can see how far they are away. I mean, the farthest 15 to 2, that's 13. So the range is 13, and the other things inside it are less far away. So the most it could be away is 13. I mean, that's range. Okay, so that means this average distance from the mean has to be less, and it's probably going to be, even closer to maybe half as much if that mean was right, if it was somewhat symmetric and that mean was right there in the middle. So by looking at this, it's definitely not 26, probably not even 12. It's definitely not 15, and it's not 0, because 0 is, that would mean every single piece of data is the same. In order to have a standard deviation of 0, every piece of data is the same. And we'll see that actually in, I think, another question. All right, so moving on, that is why I answered it this way. Therefore, I expect it to be somewhere, mostly near half of that. If the data piece 2 was actually a 22, what would have happened to the standard deviation? Well, I can tell 22 is much different, much further away than all of the other pieces of data. So I would probably consider it an outlier. So that definitely is going to be changing the standard deviation, making the average distance from the mean much bigger. So the standard deviation gets larger. All right, next. Why do we need to measure variability? Because so we have an understanding of that typical distance from average. We have to have an idea of what is on average, I mean, like, what's way different? What's just regular difference from the mean, okay? All right, if we want an average distance to the mean, why can we not just add up all those differences and then take the average? Okay, I've said that many, many times. We cannot just sum up this little section right here because these numbers would sum to 0. And you can't take an average of 0. 0 divided by 5 or whatever would be 0. And that average distance from the mean isn't 0. That's why we had to square it, okay? So that we had positive data. And so the negative and positive would cancel each other out. Next, identify these standard deviations from smallest to largest. So smallest standard deviation, most closely clustered around the mean. That's your data set 2. And then middle would be this green one. That's data set 3. And then the largest data set 1. More spread out, more varied, largest standard deviation. And then we've already discussed standard deviation of 0 means all of those values are the same because the average distance from the mean is the mean. There has to be like every piece of data is the mean so that there's 0 away from the mean. All right. I hope that that helped and that you did well on your assignment about the concept of standard deviation.